Welcome to this video on BGP Flow Spec, which was introduced in the Cisco XR software in release 5.2.0. BGP Flow Spec is a new tool that can be used to assist in DDoS mitigation in a dynamic fashion using BGP. In order to fully understand the benefits of BGP Flow Spec, let me start with the current implementation of DDoS mitigation, which is done with the help of BGP via the remote triggered black hole. The concept is that you inject a BGP route advertising the website address which is under attack with a special community. The special community on the border routers will set the next hop to a special next hop. The static route pointing to the special next hop points to null or discard. So now all the border routers install this route and subsequently drop all the traffic and prevent this traffic from hitting your web server. So this solution works and your website is back online and there is no more DDoS traffic on your network. But however, all other traffic to your website is also blocked. The next solution is policy-based routing, wherein the identification of the DDoS traffic is based around conditions regarding match statements. For example, your source or destination address, the protocol, the packet size, etc. And actions are then taken upon the DDoS traffic. These actions can be either to discard the traffic, to log it, to rate limit it, or to redirect the traffic. So this looks like a great solution since it is done with hardware accelerators for carrier-grade routers. However, the downside is that the customer needs to call the provider, who then needs to accept and run this filter on each of the backbone or edge routers. And also, once the attack has been identified and fixed, the customer needs to call the provider and remove the rule. BGP Flow Spec is an option which, when compared with other solutions, makes static policy-based routing a dynamic solution, and it uses the existing control plane communication channel to propagate these policy-based routing rules in the network. This existing communication channel is the multi-protocol BGP infrastructure. The ideal deployment is for the service provider to utilize a central flow spec speaker and have it BGP meshed within the service provider routers. Only the central flow spec speaker is allowed to distribute the flow spec rules. The central flow spec speaker is trusted in the network and is managed by the service provider. In order to disseminate the existing flow specification rules, a new NLRI is defined with AFI 1 and SAFI 133. It allows for the following 12 parameters as shown in this slide to be defined. The important point to note here is that the flow specification component must follow strict type ordering. A given component type may or may not be present in the specification, but if it is present, it must precede any component of higher numeric type value. The flow spec available actions according to the RFC 5575 is also shown in this slide. We also support one non-RFC 5575 flow spec action, and that is to redirect to an IPv4 or IPv6 next hop. Following is a BGP Flow Spec tuple support for IPv4. As you can see, there are certain flow spec types for which a multi-value range is accepted. So, for example, an IPv4 source or destination port, or an IPv4 packet length, or the IPv4 protocol and the IPv4 DHCP values could be a multi-value range. This is a BGP Flow Spec tuple support for IPv6, which is quite similar to IPv4, except that there is no support for IPv6 flow label. Following is the BGP Flow Spec extended community actions. Once the traffic matches particular criteria that you have specified, certain PBR actions can be taken on the traffic. You could drop it, police it, redirect it to a particular VRF, set certain DHCP values, or alternately redirect it to a particular IPv4 or IPv6 next hop. So, before you implement, there are certain things you need to keep in mind. The current supported scale is 3000 for simple BGP flow spec rules per system. When the flow spec rules are complex, using multi-value ranges for the BGP tuples will consume more TCAM cells and will reduce the overall scale of the system. Also, the scale of other TCAM-based features like ACL, CORS, etc. in the line card will decrease the TCAM space available for BGP flow spec. In terms of your performance impact, since the BGP flow spec internally uses PBR infrastructure for applying flow spec rules, it will incur the same performance cost like any other PBR policies. Performance costs will also vary depending on the action. For example, if you're marking the traffic, then it is less expensive than redirecting the traffic upon which a recursive lookup is required. In phase 1, coexistence with other PBR phase features like your PBTS, etc. won't be allowed with flow spec, as only one PBR feature can be associated with a given interface on a line card. While programming in hardware, a limit of 5 multi-value ranges of various flow spec tuples is supported. And finally, a mix of address families is not allowed. So in BGP flow spec rules, for IPv4 NLRI cannot have IPv6 traffic filtering actions and vice versa. Following is a setup that is available in the CPOC London labs for you to come ahead and see how the BGP flow spec works. You can see in the network that most of the traffic that is sourced from traffic generator in port M to port N is flowing through the direct link between PE4 and PE3. What we have for you is a BGP flow spec server, which is basically has an iBGP peering with the PE4 router in the network. This BGP flow spec server is used to insert certain rules in the network. The first rule is all of the customer 1 traffic, all of the customer 1's UDP traffic, which is going to the web server on VLAN 10 is dropped. Then all of the customer 2 traffic, which is going to the gaming server on VLAN 20 on ports which range from 135 to 139 or 8080, is policed at 1 meg. And our third rule, where all of the customer 1 traffic that is going to the WAT server on VLAN 30 and port 200 is redirected to the next hop towards PE1. So by default, all of the other traffic uses the direct path between PE4 and PE3, and only that certain traffic going to VLAN 30, going to the WAT server on port 200 gets redirected to PE1 and then reaches PE3. So this demo is available for you, and you can come ahead to CPOC London to see this to see BGP flow spec in action. Thank you. I hope you enjoyed this demo, and I hope that you found it useful. Go ahead and subscribe to the YouTube channel to the Cisco CPOC YouTube channel for further videos on interesting Cisco technologies. Thank you.